Hi friends, Mrs. Gradney here to welcome you back. Today in our lesson, we'll be solving multi-step word problems. Let's get started. Throughout our lesson today, we'll be using the problem set, so make sure you have that in front of you. And we'll also be using the RDW process, just like it tells us in the directions, to help us make sense of what the problems are saying. So let's get started. Let's read problem 1 together, and then we'll go back and we'll read it in chunks and we'll draw as we go. Ready? Read. Over the summer, Kate earned $180 each week for 7 weeks. Of that money, she spent $375 on a new computer and $137 on new clothes. How much money did she have left? Now let's go back and let's reread that first chunk. Ready? Read. Over the summer, Kate earned $180 each week for 7 weeks. Okay? Now, can we draw something to represent that part of the story? Yes, we can. What can we draw? Let's draw a tape diagram with 7 equal units to represent the 7 weeks, and each unit with a value of 180. Now, do we know the total value of this tape of all 7 units? No, we don't know the total value yet, so let's label a question mark here at the top to show that we don't yet know the value of all 7 units. Now, let's read the next chunk. Ready? Read. Of that money, she spent $375 on a new computer and $137 on new clothes. Okay. Can we draw something to represent that part of the story? Yes, we can. What can we draw? It says of that money. And when it says of that money, it's talking about all of this money represented in this tape. And so she spent some of this money here. So let's draw another tape right underneath this one. That's the same size, because they have the same value. And let's show that of this money, she spent $375 on a new computer and $137 on new clothes. Let's read that last chunk. How much money did she have left? Can we draw something? Well, we can definitely add our unknown now to our tape diagram. Where in our tape diagram, what part of it represents the unknown that we're looking for? How much money she had left? Point to it. The unknown, how much money she had left, is represented right here. So let's label this part with a variable. I'm going to use the variable M to stand for money. And now we can see the part that we're looking for. Now, let the tape diagram speak to you. What does it tell you about how you might solve? Now, pause the video and solve the problem using numbers, write the value of the variable, and be sure to write an answer statement. When you're done, come back and we'll compare our work. Welcome back. Did you find that Kate has $748 left? If you didn't, be sure to pause the video, compare your work to mine, and see if you can find your mistake. Now here, I'm showing one way that you could have solved it, but it's not the only correct way. Here's what I did. First, I found the total amount of money that Kate made over the summer here, and that told me the value of this whole tape. Then I added the amounts that she spent to find the total amount of money that Kate spent. Then I subtracted the amount she spent from the amount she made to get the amount that she had left. Now, we could have also found the total amount of money that Kate made over the summer, and then subtracted the amount that she spent on the computer, and then subtracted the amount of money that she spent on clothes one at a time. That would have been correct as well. Let's move to problem 2 now and read it together. Ready? Read. Sylvia weighed 8 pounds when she was born. By her first birthday, her weight had tripled. By her second birthday, she had gained 12 more pounds. At that time, Sylvia's father weighed 5 times as much as she did. What was Sylvia and her dad's combined weight? Now, pause the video and draw a tape diagram to represent the story. Remember, if you get stuck, ask yourself, what can I draw to represent just that one part of the story? And when you're finished drawing for the whole story, come back and we'll compare our drawings. Welcome back. Here's my drawing. Does yours look similar? Now, let's talk about how this tape diagram represents all the information in the story. Where does this 24 come from? What does it match in the story? Pause the video to talk out your thinking. In the story, we don't see the number 24 written anywhere, but it represents Sylvia's weight once it had tripled. So how much she weighed by her first birthday? 8 times 3. But I did the tripling in my head instead of drawing 8 3 times or drawing 3 units of 8. But if you drew 3 units of 8, that works too. Then this 12 represents how much more she had gained by her second birthday. Together, 24 and 12 represent how much she weighed by her second birthday, and that is 36 pounds. Then we have a tape that represents her father's weight. Her father weighed 5 times as much as she did, so we can see 5 units the same size as Sylvia's. And we're looking for their combined weight, and we can see that represented here with the variable W. Now let the tape diagram speak to you. What does it tell you about how we might solve? Well, there's definitely more than one way to solve. So pause the video here and solve the problem using whatever strategy you'd like. Write the value of the variable and be sure to write an answer statement. When you're done, come back and we'll compare. Welcome back. Hopefully you found Sylvia and her dad's combined weight is 216 pounds. On the screen, you can see one way that you could have solved the problem, but it's not the only correct way. Did you think about it in a similar way or in a different way? Here's how I thought about it. In my tape diagram, I could see that Sylvia's father's weight was 5 units of 36. And then Sylvia's weight was another unit of 36. That's 6 units of 36. So I multiplied 36 times 6 using the standard algorithm. We could have also used the partial products method or an area model.